Okay, so we did the worksheet yesterday. Now I want to show you something related to that worksheet, but also related to something we're about to do. So let's say I have a circle. Look, something like that. If my art was good, though, that would be no fun. And let's say that this circle has a diameter of 1.6 inches. And this angle in here is 70 degrees. How do I find the area of the triangle? This area right here. Yeah, you'd have to subtract the segment out here. And remember how we found the segment was we found the sector and subtracted the triangle. It's easier to find the triangle than it is to just find the segment. Now, one thing, of course, we know that this is going to be 0.8 inches here and 0.8 inches here, correct? Remember something we used called Hero's formula? If you knew the length of this, then you'd have all three sides, and it's the perimeter divided by 2 to get the semi-perimeter. Remember that one? Well, we're not going to do it that way. You could do it that way. You could use law cosines to find this length out here. And then you could use Hero's formula. That would be the long way. Now that we know trig, there's easier ways to do it. I'm going to draw that triangle like this now. So this is 0.8, this is 0.8, and this is 70. If I knew this height here at a right angle, it would just be this times this divided by 2, right? 1/2 base times height. Well, I know that height, because that is the opposite side according to the 7-degree angle. That's the hypotenuse, right? So if I'm going to call this h for height, sine of 70 degrees equals h over 0.8. If I put this over 1 and cross multiply and divide, h equals 0.8 times the sine of 70 degrees. So the area of this triangle is the base, 0.8, times the height, which is 0.8 times the sine of 70 over 2. Does that make sense? In fact, for any triangle, let's say this is 8 inches and this is 13 inches and this is 68 degrees. For any triangle, if I'm going to label it like this, A, B, C, so this is little a, little b, little c. The area of the triangle, I'm going to actually write out the word area so you don't confuse it with angle A, is equal to side A times side B times the sine of angle C divided by 2. That's when I have two sides and the angle in between them. In other words, a situation where I could use law cosines. Does that make sense? So back up here, the area of that triangle is simply then 0.8 times 0.8 times, so 0.8 times 0.8 times the sine of 70 degrees over 2. Gives me 0.3001, or 0.301 square inches is that area. Does that make sense? So assume there's the 3 zeros. These are out to the thousandth. I just didn't put the extra zeros in there. So assume we have these two circles who overlap. Their centers are 1.7 inches apart. You have the given diameters. I want to find the area of this kite-shaped piece in here. Well, so to do that, I'm going to cut it in half. Once it's cut in half, I know that this is 1.7 inches, correct? I know that this is 1.2 inches and this is 0.8 inches. Make sense? Got diameters and then I got the center to center distance. But I don't know no angles. Well, there's good English for you. I don't know any angles. I don't know any of those angles. But because I know all three sides, I can find them. I'm going to pick this angle here, and I'm going to call that angle C. So A and B. So this is going to be little a, little b, little c. And remember, our law of cosines is c squared equals a squared plus b squared minus 2ab cosine c. So I'm going to fill in here. Side C is 0.8, that's squared, equals side A 1.7 squared plus side B 1.2 squared minus 2 times 1.7 times 1.2 times the cosine of angle C. And remember, we're treating this like the variable. We're solving for the cosine of C right now. 0.8 squared is 0.64. 1.7 squared is 2.89. 1.2 squared is 1.44. 2 times 1.7 is 3.4. Times 1.2 is what? 7.48 or something like that? Yeah, let me try it. 2 times 1.7 times 1.2. 7.08 or 4.08. Times the cosine of C. Now I can here combine the 2.89 and the 1.44, which is going to give me what? 4.33. And then I subtract 4.33 from both sides, giving me what? 3.69, negative 3.69 equals negative 4.08 cosine C. And I divide by negative 4.08. So what I'm getting here is that angle C is going to be the inverse cosine of the 3.69 over 4.08. I didn't divide that out because I really don't have to. Second cosine, 3.69. Notice I left the negatives off too because the negative divided by negative will be a positive. Isn't it? C is 25.26 degrees. Look good? Yes? No? (25.26 degrees). Now here's what I'm going to do. Before I get that on my calculator, I'm going to multiply by 2. Because what I really want is this angle here, which is 50.51 degrees. Now the other angle that I want here is angle B. I wouldn't want to find angle A first anyway. Why would I not want to find angle A here? It's across from the largest side, so it might be obtuse. We're not sure yet, are we? It might be obtuse, it might not be. But we know that angle B has to be acute because it's not across from the largest side. 1.7 being the largest side, A is the only angle that could be obtuse. So let's find angle B. So we have 0.8 over the sine of 25.26 degrees equals 1.2 over the sine of B. So clear that out. Sine of 25.26 times 1.2 divided by 0.8. 0.6400 or 0.6401. Now we're going to do the inverse sine of that. Gives us 39.80 degrees. So it looks like A would be obtuse here. Now again, the 39.80 isn't really what I'm looking for. I'm looking for this bigger angle. So times 2. 79.60 degrees. Why did I care? Why did I want those two angles? Because now I can cut it like this, and I have a triangle here whose area is, if this is 1.2 on each side, is 1.2 times 1.2 times the sine of 50.51 degrees divided by 2. Give me that area is 0.556 square inches. And in the other circle, I have that triangle, if this being 0.8, is 0.8 times 0.8 times the sine of 79.60 degrees over 2. Given that area of 0.315. Adding the two of those together gives us a total area of 0.871 square inches. What do you think of that?
That has to be the word problem we went over all year.
It'll get worse, don't worry. Your mission for today is going to be, between the four of you, problem number 1 on your worksheet from yesterday. Find the area of the whole thing. So you had the overlapping circles like this. Find its area. I'm not going to say whether what we just learned applies or not. But you do know this little formula now for finding the area of a triangle. You guys can work together as a group if you want to. You can use the board if you want to. Before you leave here, I want an area for that, problem number 1. Okay, here's huge hint time. Think you got her? Cool. We actually looked yesterday at how to cut this across here to make this a rectangle. Once you've got that cut like that, once you know this length here, once you have that length, which we did figure out yesterday, you already know this length. So you can find the area of the rectangle, and you can find the area of the triangle, and then you got the exact same thing over here. So it's just a matter of getting these angles, which we figured out how to find yesterday. Find the area of those sectors and adding them all up.
You know, I thought of that.